Lovely. All right, so what are we doing here, right? We're trying to make things more ergonomic so that people can contribute easily and follow best practices when they do that, and then still extend without the data flow mechanisms if they want to, right? But basically just facilitate that clean interface. So via these classes. So let's see. So we need to run the operation. Data flow. Self-config. Okay, it does that input conversion, which is like what we did for the system context stuff recently. It's not the real line numbers, but on the screen right now, 381 through 384. That's that conversion that we did in the system context. Okay, so all right, so config data flow. So we want to grab the orchestrator context, config data flow. We want to run the subflow. Okay, so it's going to give us an orchestrator context. So that's what this is. So run default, run custom. Okay, so run custom, run default. Okay. So what do we want to do? We want to have this. We want to call this. Let's see. I'm going to call this run custom. This thing's going to be an op, so it'll have self. So when it runs through self, it'll have that self parent op inputs items. So could we just do? Yeah, I think we can just do. I think we can just do run data flow dot run custom I think we can just pass self and it will do self.parent.op inputs item. Okay, it'll grab the context definition. Okay, context definition list. So basically the first input is treated as the context. Weird. Okay. Okay, so it's building one for each context. Context okay. So yeah, so the first one is inputs. So basically the first input, yeah, is the context. So whatever we make the first input here will be the context. So what we want then is this get repo spec actually to be the context, right? So this is what we want to be the context. And so if we do that, yeah, Yeah, we say that it's a give repo spec. So this thing takes a give repo spec. So then we have something else that generates the give repo specs. And that is this one, but it doesn't do the execution. Repo CLI. Or let's see. Okay. Give repo spec. Okay, so this would be, no, so this would actually be, repo would actually have to be a, okay. Okay. So because we have to make a separate definition here, or else, so we have to make a separate definition to scope it. So then this one can return CLI run on repo. CLI is meant on this repo. Async iter CLI run on repo. Okay, so now we yield. Okay, yeah, so now we yield this give repo spec, but it's going to be interpreted as this CLI run on repo for now, and then we'll do the typecast later effectively. When we execute it within the subflow, then we typecast, right, over to get repo spec, and this is what prevents these operations from running recursively here. So, okay, all right, okay. Okay, so this should do CLI is meant on this repo. Where the hell did this come from? What was this before? Okay, if not, command.repo. So that's a very important part of this. Yeah, so if not command.wide or not command.return. Okay. All right, so basically if you're running from the CLI, and then we'll probably just throw a decorator on this to make this a conditional, right? And then it would do the value check. But for now, because we want to have parity with non-orchestrated code, we're going to go with this direct variable here. Okay, so async iter. All right, so what does that mean? That means yield os.cwd get cwd. Okay. And this is actually not going to be that. This is going to be that. Okay, and this is going to take that. Okay, and this is string repo string to spec. In need spec, right? So read of typecast. Okay, so repo string in need of typecast. Okay, so and this will do this CLI bound repo, which will actually be this here. Okay, so this is, no, let's not do it that way. Let's not do it that way, because the other ones know the URL. And this really should be. Okay, so all right, so, oh, wait, what? So this is all we need to do now. All right, we just yield this get repo spec, and in this one over here, this becomes a for loop rather than a generator, and we do repo, and we maintain our to-do. Right, okay, so now we yield them all. Fantastic. Okay, I don't know if we have non-async iter support, so I'm just going to throw async on this. It's because I don't think we have implemented the non-async iter support, but it's just a typecast. It's we already had. So so let's see. Okay, CLI run on repo. Okay, so this is the one that's actually going to do our work here, right? So this is going to be also this async iter, right? And this is going to take CLI run on repo, right? So the local class local scope, which my understanding is the type checker should resolve, but for some reason Python does not. So CLI run on repo. Okay, so this thing finally takes this CLI run on repo, and it's already checked if it's wanted, right? So because it's, by the time it gets here, it's like, okay, I know I'm running because I got these repo objects, so it doesn't have to check wanted. All it needs to do is concern itself with the type conversion here, which eventually what we'll do is have this be something that operates similar to expand, and yes, of union we would have system context, right? And then the class, which then transforms and is used as the base context, and also so whatever this class is going to be like our base context handle, I believe, within df base. And what it'll do is it'll basically be something kind of like we have record context, string context in there, and in memory, in df memory, we will basically have subclasses. Remember that all of those become the system context, and so then that handle, when we go to grab the handle to do the resolution, and we do the await the handle, that's where we can resolve DIDs and stuff if we need to merge the overlay to create the, to synthesize the new context, I believe. or like to do whatever methods that we need to do when we grab the handle. We await the handle. That I think allows you to enter the system context where you can then, do the links, right, that we were talking about, where you need to, resolve the DID peer links or something. So because then you would apply the overlay. So you would do it async with the system context, right? And now you're within it, right? And so this is all happening in await handle, ctx.handle. And then you're calling, some whatever resolution methods need to happen, whatever the deployment, right? So you apply the overlays, you run the deployment, which is context handle, and you return the value from the await. And so you can do that with the input network stuff that we talked about. You can take we can have those specific input sets, and so we can have these subclasses of them and the input objects themselves, and so that when you're operating with an input set, which is maybe like a Redis input set context or something, then when it did its handle method, it would basically just know that, hey, this is where I go and run that. That handle method is if it was a system context as class, the handle method is that deployment where it goes and resolves whatever its handle object should be, right? And then off that handle object, it can do the string representation, right? And so sometimes we need to resolve parents if we were going to do a dump of a whole string representation if we wanted to, right? And so in that case, then you could do that, right? And it would apply the overlays appropriately. Okay, so, and you could do things like access control and stuff within the overlays and your RBAC. So and how do we do that? So we basically just take system context and we say read, get, grab, record, system context. Let's see. So string input set context. So this input set context is the system context. Memory input set context. Okay, so we would say string input set context, or we would say, string input set context. So system context, string input set context, and then what is the output here? So the repo spec, right? So this says now if we were to run custom, okay, so this would be, okay, so this is like the event here where you have so this is the future. This is the future, right? So we'll have this union structure and then another union structure, right? And then the return value of the function. So then basically you just return whatever the hell you want from this. So basically return repo, right? That's effectively a typecast, right? And yeah, it's effectively does a typecast. And so you could have an operation implementation network which understands this, right, by some means. Like maybe we could have we could have an even more shorthand syntax for this. So maybe it's like So repo, CLI run on repo equals system context, string input set context, spec. Yeah, that could work too. That could work too. So this says basically, CLI run on repo. No, you don't really need that. I don't know. Yeah. So there's something more that we can do there that would be even more like clear. Like something so much so as if we could use that operator right there, I mean, and just have it, you know, up here, right? That would be ideal. That would show that we would be able to analyze that for a type conversion. So that would be great, but we can't do that, I don't think so. Okay, so now if we just do run custom, and then we say self and inputs, we say repo, and then repo. And I think that's that. Okay, so I think this is what we're at for now. CLI run on repo. Actually, I should put this comment within the block because that way, you know, somebody would be less likely to move the function without the comment. Okay, so async for CTX results in dataflow run custom self 912. Self repo. Okay, so that should call run custom. Okay, diff model run dataflow. Run custom self repo. Okay, yield results. Okay. So now this should do the yeah, this should do the run custom. So now what we do need to do is we do need to say self dot. So where was that? Okay, so config dot data flow. All right, so self config data flow. Self config data flow. Okay, so yeah, self config data flow, and that is in a operation implementation context. Okay, so self config run data flow equals, and I'm not sure if the config is immutable here in this situation. I don't think it is. I think it's a base config. So we would run into that if we had a config on this. So let's see. So equals self dot parent or self dot octx dot parent dot config dot data flow. Okay. So now this points the data flow property of the CLI run on repo class, which gets created, the implementation class, the implementation context class, which gets created to this, and then we run custom. Okay, so async iterator is not defined. Okay. What do we got? Okay. So this one was never weighted. Wait. So it is. Well, that's fine. We only have one. It's a one-to-one mapping. So I think it'll just run it. It'll end up just running it in a different side. All right. So we'll just do a wait. That's even nicer looking. Okay. So CLI run on repo was dispatched twice. Okay, so, and something decided. So CLI is meant on this repo decided that it wanted to. So let's see. So now, yeah. So CLI is meant on this repo decided that yes, I am. If not wanted. If. Okay, so that was the problem. Okay, so now we should only have one. Okay, test A. Okay, so invalid custom run data flow context. Okay. Invalid custom run data flow context. Okay, so let's go to 190. Okay. If context definition primitive does not equal string. Okay, fair enough. Fair enough. Okay, so so quick hack for this. So far. Okay, so why do we even need to do this right now? Why do we even need to do this right now? Okay. Just make it a string. Okay. Okay, so let's commit this. Okay, so CLI, so running okay, running some subflow using function or type fast. That was pretty cool. Okay. Okay, so okay. So I think what we need to do is just have this be a string, and then here what we'll say is implemented community standards. So s repo string is URL. Okay. is how bad is this? That is where okay. Okay, so this is repo string, or let's say this is, yeah, repo string. Okay. If repo string repo string. Okay. So then we need to do repo string. So those will handle that. So then this just needs to do repo string. Repo string. Okay. CLI run on repo. So this CLI run on repo is really a string, and we're going to also hot swap the definition. So self inputs repo equals. Okay, so this is where we hot swap the definition for this repo string. Okay. Okay, so we've got some. Okay, so this is just repo. All right, so we're adapting to our limitation around the string context for now, so we don't have time to patch. Okay. Okay, so repo string diff of 116. Okay. CLI command. So where is this defined? So we just need to bring this up. Where is it being used? So CLI has repos, but this shouldn't be in there. So okay, I just copied it there. I think we're good to remove it. Okay. Function. object has no attribute primitive. Okay, so 244. Okay, so repo string. Okay, so this needs to be a definition. So op dot replace inputs. Okay. Okay. Use control C run on repo. Okay, so parent op repo. Okay, so out of time here, so I'm gonna have to get so alright, so I'm just gonna make copies of everything. Custom run data flow equals copy self. So run data flow dot config config. Okay. Data flow. And then the data flow equals the OCTX data flow, and the parent op equals the replacement. Okay. And then we pass the custom run data flow as the self there. Okay. Something like that. Self dot op. Self dot imp. Okay, self dot parent dot imp. Data flow. X. Okay. Okay. This should create a new instance of the class. Okay, fuck. Feel like on repo should be being. Okay, what is self? Okay, so this is an implementation context self.parent dot parent. Okay, that is the implementation class. Okay. It's missing CTX and OCTX self.ctx self.octx. Invalid. Okay. This thing is still getting. Okay, so CLI run on repo. Okay, so it's getting repo.string now, which is the correct one. And invalid custom run data flow context. Okay. Okay, so please contribute. Okay, so okay, so okay, so that doesn't have to be a deep copy there. Okay. So we do the type, this is the type conversion. Sure, we need to later reuse ICTF or something. Okay, so let's just do this. Okay, so let's see. Execution repo string guessing. Okay. Okay, so invalid customer data context. Okay, so name repo.string primitive string. Okay, so okay. Now let's go find our nice helpful error. So primitive does not equal string. So primitive, okay, does not equal string, so it equals stir. So this is easy fix. All right, there we are. So where are we at? Okay, so get repo spec. So we saw repo string guess is directory, come out as none, guess is URL. All right, fantastic. So it started, it should have started a new context. Look, and so it did. It started a new context there. This is cool. So the thing is, I don't know if we're waiting for that context right now. So that's a potential issue. So oh, that was cool. Okay. Is this in run custom run? This one. First input definition used as context. Now supports auto def string stir primitives detection. All right, yeah, and that's a mouthful of my message there, but it's fine. It's better to just have it than to fuss about hitting 50 characters. Okay, so we can rework everything in visualization later. Okay, so yeah, worried about that. Not. Time check 937. Looks like it's not. Okay. I have faith. Okay. Right. So let's go to do. Okay. So here we see the kickstarting of the context. These are the ones that we're watching by default. So you notice that this does not have the same thing as above. So this is a little bit simpler, or then below than the run operations for CTX. And why is that? Well, it's because we're missing something. We're missing this input set and enters network. And so let's see, what is the yield here? So the yield is CTX results. Okay, so now what we're going to do is we're going to implement support for watching. Make sure there's no disk. This file. Watch out for this file. It's the hairy file. Okay, so look at this function. It's a beast. All right, so what we want is to also listen for run operations for CTX, create tabs. We want this thing to listen for new context. Because right now, task set. Okay. Run operations for CTX. Okay, so maybe every time run operations for CTX is executed, every time when operations for CTX, it's so much easier to write it in the data flow. We'll convert this eventually. Okay, so when operations inputs it in intrusion network self ICTX. Okay, return when I see new version shell. Puts it intrusion network. So we need to have a way to feed it input set enters network. So we need to have a way to feed it similarly to the way we feed the, okay, so input set enters network. And that is for if it's added to this context, right? So the inputs that enters the network. All right, come on, we want to watch for some more of these. All right, so what do we need to do? We need to have a similar thing which says, are we on YouTube? We're on. All right, so we need to have a similar thing. 42, all right. Okay, so if we make this work, what's going to happen, right? From the top level loop, so what's going to happen if we do this, right? So this here, this is now going to return more than just once, right? So this was a a critical difference here in the way that it used to be and the way that we are now operating, right? Is we're now thinking in parallel. So this is how that's happening, right? So this is how we make Alice think in parallel. So okay, because right now she's just waiting on a predefined set of tasks. So run operations for CTX. So let's get into run subflow. So subflow. So let's say def subflow. Okay. So I think that might be in df base run subflow. Okay, so async def subflow. Okay, so within subflow, and so I think this is where we have our still yet unworking overlay support. Yes, okay, so this is going to run into a problem here. Okay, so, but overlay we can just set to none. Okay, so we'll set overlay. Overlay is already none. Okay, so overlay is not none. Okay, so this requires overlay is applying. So, okay, so, but it's not going to default to that, so we should be good. Okay, so we should be good to skip the overlay code, which might be broken. And then, okay, so async def subflow. Okay, so what do we want? So we want subflow, so self OCTX. We want this to trigger an event, so that says OTCTX. So this says async with OCTX parent data flow as OTCTX. So that's going to create a new orchestrator context. So how does that create a new orchestrator context? Well, are we in, what file are we in? Okay, so let's go into memory. Let's go down into the orchestrator context here, right? So this is going to call this function. It's going to create this, which is a memory orchestrator context, which is this guy, right? So what is this going to do? So it's going to create new, so it's going to create new redundancy checkers, input networks, operation network, lock networks, and input an operation implementation context network. So it's going to create new of all of those unless we specify them in config reuse. So we're going to need to pull these out, and we're going to need to configure to reuse them, right? So that we don't end up with new copies, because we want this to execute seamlessly within the same flow, right? Within the same execution context. So you could, this basically, what this does is it effectively, this is a trust boundary which we instantiate here upon different contexts, but we want to blow through that trust boundary in this instance and just say, hey, reuse that previous stuff. So let's see. Actually, does that even matter? Do we care about pointing to the trust boundary? So redundancy checker. Fuck it. Yeah, no, just give it a new one. Who cares? So, but we could do other things in here. This is really interesting. Okay. So, so it shouldn't matter, because then, or well, let's see. Should it matter or shouldn't it matter? So when we say subflows, so here's subflow. Okay, so we create a new context, right? It's got its whole own environment. Okay, but now we say self OCTX subflows, and then this instance. So we say, hey, by the way, here's a subflow hanging out in case you want to do any forwarding. We have this notion of forwarding. So for running flow, you can continue to send new stuff to it. So because I don't know if this is really a concept that we need to keep, or if it was just something we implemented and we didn't really understand at the time. But I think it still has value. I think it's like, you can have these long running subflows and forward inputs to them on demand. So is that actually what we're doing here? Yeah, if you reuse the input network context, then if you reuse the operation implementation context, then you can have these long running subflows effectively, or you could have ones. So we're just going to basically institute a trust boundary and keep it like this. Okay. So self.subflows instance name equals OCTX, yield OCTX. Okay, so now we have a new orchestrator context. So now we want to be notified in the parent flow anytime the subflow executes. So is it not that, but that doesn't make it a subflow. So that means that would be if we wanted to get events from subflows. But we do want to get events from subflows. We want to get events from all flows. Right? So anytime there's results, we want to know where it came from. So that means that CTX should have a reference to what orchestrator ran it. So CTX needs to have a reference to what orchestrator ran it when it's yielded there, because we're going to have many different orchestrator contexts. So CTX needs to have, so to do, Alice, CTX, CTX is the system context, which means it, of course, has an orchestrator object on it. Okay, is the system context. So it will have an orchestrator property on it with the orchestrator, which is yielding these results. All right, okay, so, all right. So, all right, so I'm satisfied. So I think what we'll do here is say OCTX subflows, OCTX subflows, OCTX equals system context. Okay. subflow system context. Are we leaving? Okay. So this makes a subflow unique. Okay, so this makes a subflow. Oh, because it creates an orchestrator context. This doesn't create a subflow. This creates an orchestrator context. Right, so if you wanted subflow system context, okay, so if you wanted to use that effectively, okay, run custom. Okay, so run custom. So within run custom, we would say, okay, so now, okay, so we're, yeah, okay, so we're manually instantiating a new orchestrator here. We need to be responsible and we need to notify our orchestrator that we just did this, right? And we need to say new subflow system context added, okay? And we pass the instance name and the orchestrator. Or no, so we do actually, yeah, we do. Or no, we just do the context. Yeah, because that context will have an orchestrator on it. Okay, so CTX run. Okay, so this CTX. So CTX dot upstream, CTX dot overlay, and CTX dot orchestrator. Okay. Okay, so OCTX run. So for inputs. Okay, so run. Okay, so in run. So this probably belongs in run because we could say parent equals OCTX, and then we could do this here. Alright, config data file, okay. CTX overlay. Okay. It's upstream plus the execution of this operation. Okay. 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 Okay, so but we will set the orchestrator. Right. Okay, so and we'll say equals parent. Okay. So let's head over to memory. Okay. And we're in run here. These functions are geese. Okay, so this is if we have a parent operation. Optional. System. Base orchestrator context. All right. Because the base orchestrator context, if there's a parent, it'll tell us what data flow it's executing, so where we're coming from. Okay, so where is it going to say? So seed inputs, CTXS. Okay, so basically kickstarting context. Okay, now we're here. So basically, yeah, so kickstarting context. Run operations for CTX. Okay, so run operations for CTX. So where is CTX created? Okay, C inputs. Okay, so here's all the CTX. Okay, so by the time we get to here, grab the context by its index. So basically, CTX index. Okay, in range. Okay. Non-CTX. Okay, so get the number. Okay, launch it. Go through non-CTXS. So this context structure. So here, we say if parent is not none, then we add ctx.orchestrator equals parent, and we say self dot octx. Okay, so no, we'd say parent dot subflow system context added. Okay, so and then the CTX, right? So then it's going to kickstart it. Okay, no, so CTX dot orchestrator equals parent. Okay, no, CTX dot orchestrator. Okay, CTX dot orchestrator parent equals parent. Okay, CTX dot orchestrator. CTX dot orchestrator equals self. Okay. So we have orchestrator and orchestrator parent. Okay, come on. And then okay, parent. Okay, so CTX orchestrator parent. Okay, so in run operations for CTX, we say if there is a parent, right? So this one, sure that we always catch it because here we have a consistent, there's no like kickstart, mechanism, it's consistent. Let's see, dispatch auto starts. Okay. Pass add task. No, that's not consistent. Okay. Dispatch auto starts. CTX, so we need it on dispatch auto starts. So dispatch auto starts. Okay. CTX dispatch. Okay, where's the right place for this? Self ICTX and CTX dispatch. CTX, what is that? And CTX is the op-amp network. Okay, the op-amp network is a good place. Or no, it doesn't even matter. Okay, yeah, it's run operations for CTX. So basically, dispatch, auto starts, CTX. Okay, so in here, I think it's just if we are a subflow, send events to as well. Okay, so flow system context added. Okay, so this is basically going to say flow system context added. So this is going to be so what are we going to do here? Anytime we yield here, okay, now this returns, okay, because this runs a single context. So we need to somehow watch this task object. So run operations for CTX. So this thing is only ever called from here. Okay. Okay. Run operations for CTX. Okay, so run operations for CTX. Okay, so what do you want here? You want to listen for read event on this. So whenever you do a create task on it, you need to, so you create the coroutine, you say here's the, you say hey, there's going to be stuff from this. Okay, so we need to capture that. Task or, yeah, you say create task, run operations for CTX. Okay, so this is now like the monitor or something, right? So you basically say you need to pass up the thing that does the monitor. Or let's see, could you just have it say here? Okay, the right way to do this is not the way we're going to do it right now because I'm running out of time. So the right way to do this would be to use the monitor code. Um, so okay. So what do we want? We just want it to run operations for CTL. Okay. Okay. Subflow system context added. Okay, if has add to CTX orchestrator parent. Okay, subflow system context added. Okay, so then we can say here, what are we doing here? So ICTX added. Okay, let's just assume subflow system context added. Let's assume this is a reasonable function. Okay, and what does this reasonable function take? Okay, and that is the same thing. So if it's past parent, so let's make sure that we're passing a parent. Equals OCTX. Okay. Or wait a minute, no. Parent equals self.octx. All right, okay, so that would be then we'll call runs this method that we're about to write right here. We're going to call this on the parent, which is going to be here, right? So forward inputs to subflow, and then this is subflow system context added. So this is almost like the reverse of the one above it. CTX base context handle. Okay, so what does this do? Forward inputs to subflow. Okay, so we kickstart task create task, and now we go down here and we grab this code that says, that talks about input set enters network, right? So we're in this subflow. We triggered that system, that one, right? Okay. So we want to know when input set enters network. Actually, we're just going to take this whole function and it's a beast. Okay. Okay, so now here we are in run, and we want to implement similar functionality in run. All right, so while tasks, okay, so try while tasks. Okay, so now we are happy with our existing exception handling code. here. So this validator stuff, this is no longer applicable. So new input sets. Okay, so input set network, input set interest network. So ictx.added, added. So added does this notification set thing. Okay, no, okay, so this is the added. So what we really want here is to use, okay, event added lock. Okay, so this is base input set. Okay, so watch CTX. Okay, here notification items added. Okay, so should we just use a input network? We could say watch CTX base input set context. Okay, so added. Okay, okay, so it is a handle. Okay, so we just say, hey, we added this new thing. So this is just, so basically this is a reverse subflow forward, right? So this is a reverse of what we just did. And so how do we do that? Well, we forward, how does the subflow forward inputs the subflow? Receive from parent flow. All right, so ICTX receive from parent flow. Okay, receive from parent flow. Okay, so then this adds. Okay, from parent flow. Okay. I think this is from child flow now. I think we just say from child flow. Child's data flow to watch for results. Okay, so 1013. Okay. So takes context from child's data flow to watch for results. Okay. Receive from child flow. So this is CTX. Receive from parent flow. So self.ictx.receive from child flow. Okay, so this base context handle. Okay, so we receive it from the child flow, and then here we input set equals mark ictx.added. Okay, so we are now looking for specific context here. So CTX added, right? So now we're watching for context themselves. Okay, so context network. Okay. Okay. Context enters network. Okay, so what are we going to do with context enters network? So we're going to do CTX added, so def added within, yes, here. So wait a minute, do we have this? CTX. Does this create a new context? CTX.added. ICTX. .ctx. Nothing calls that. ctx.add, but there is no .ctx. Okay, so that method doesn't look like it's being called. So this doesn't look like it's being called. What does this do? Return await ctx.added. Is this what we're looking for? I wrote all this code and I didn't even know what it did. All right, so ctx notification set. Where is this being used? The ctx. Add memory inputs. Add. Okay, so it looks like it's saying input set.ctx. Okay, so it looks like it's listening for context additions. So I think, yeah, I think it's listening for context additions. So we could do, so yeah, I think it's listening for context additions. So what we would need, ctx notification set, and we need result notification set. Oh, wait. Okay, so ctx notification set. Okay, so and then this is anything which is coming from an output operation. Okay. Okay, so this is any time receive function. Okay. Not looking good. Okay. So ctx notification set. Okay. Okay. We want to watch for the results. Okay, so receive from child flow. Do we need to receive from child flow anymore? That's it, items. Okay, so add, where's that context? So this ctx notification set. CTX notification set says CTX notification set as add. Okay. None. Okay. So then wait for one to be added down here. Okay. So result notification set. Okay. So receive from child flow should say then receive from child flow should do CTX received context from child flow. Okay, and then the context will have what flow it is. So CTX. Okay. And then what is this none? Notification item. Okay, so just added is more. Oh, it's more. That's why it's none. So there's no more. That's it. CTX added. Okay. So the result notification set and receive from child file is subflow system context created. Child flow context created. Subflow system context added. Child flow context created. Okay. Okay. So then child flow context result. Right, and so these become deployments, become the output overlays, which we then call in. So basically we're sandboxing. What we're effectively going to end up doing is sandboxing the um, the ability that we're proposing a methodology which effectively facilitates sandboxing call two-way calls between client and server. All right, so something like a programmable GraphQL, right? And so that we see in the relationship between the child and the parent, flow context created and child flow context result. So let's see, receive context from child flow, receive result. Okay. Okay. So then okay, so result notification set context. Result notification set. Okay. Notification set. Okay. So result notification set. Result added. Okay, so and I think actually this is sort of the evolution of the monitor stuff is this notification set. Now I'm remembering. So then child flow context result. So what do we want there? We want to sit and wait for ICTX dot result within the run. Okay, yeah, so here's run. And so what do we want? We want results. Right, so to do listing for optionally for a child. Let's see. Context creation. Okay, so listen for child context creation and bubble up events per policy. So result. What was it that we just called this? And then within the cleaned up. Okay. ICTX.result. So result enters network. Okay. So all right. Yeah, so this is actually the way we should be doing this. We should be doing this with result, and then these things should be publishing to the result. Okay. Okay, so okay. Let's add some more. Result. Result. Okay, context. Result. Okay. And then this becomes, so context created, so context created. So, and then this just becomes add context result. Okay. Anything that gets sent to this will get bubbled up effectively. Okay. Okay, so CTX receives. Okay. Okay, so CTX result, so add context result. Okay. Okay, so context result, contest ICTX result. Okay, and when we get that, what is it going to be? It's going to be, okay, so more and result, and then within that, so result the okay, and then we can just nix all this. So log_debug. So now what are we doing here? So this is kicking off context, real task.results. Alright, so we're running the task no matter what it is. We're going to grab task results if task is if task is context result, okay, we don't even need that stuff. So if task is context result. So continue to watch non-exported. Okay, so I think we have to change this. Okay, to that. Okay. Okay, yeah, so basically it says, is there more? Is there more? So, is there more should say result notification set add. So it does do that. Okay. So when we're adding, okay, so that none was the unvalidated. So we can just do CTX result. Yeah. we can just do CTX result and it'll take care of more. Okay, the notification set will take care of more. Okay, so add context result. Okay, so we need to call this thing on return from run operations for CTX. And then you could go so far as to add it here on any output operation or anything. So do building of all returns via scope CTX given to add context results. Okay. Okay. CTX output. All right, so there we go. Notify notify watchers of return value. Okay, so let's not even worry about this here anymore. It doesn't even have the correct type on it anyways. Okay, so we're gonna do that. So add context result. Okay, and then we're gonna watch the context results here. So CTX. Okay, so we had to keep that. We had to remove that. Okay, so basically, so more, and then CTX result. Okay, that is correct. Okay, so if task is context result. Okay, and here, so yeah, task results. If task is context result yields. So okay, so just run everything else. If not known event. Okay. Okay. To do check return values and ways if not explicitly. No. I don't know. Maybe not. Okay, so okay. Okay, so if task is context result. Okay. I'll just grab the results and then go spin up a bunch more tasks. Okay, so let's get to this result. Delete all this. Okay, what do we got? not defined. Okay. 41. Okay. So child flow context created, add context result. Okay, result notification set, result added. Okay. Okay. Get that format diff out of there. Okay. Child flow context created. Okay, nobody's listening to that, but it's fine. Okay, so add context result. Result added. Okay. So context result isn't create. So listen for the results. Okay, so if it is a result, then yield it. Create another task to watch for results, otherwise just hang out. Okay, so basically subflow system context added. Subflow system context added. Call child flow context created. Perfect. Okay, notify watchers of return value, so we're no longer using a return. Great. Okay. So then pass the parent when we're doing run custom. Okay, so more is not defined. So okay, so df memory. Okay. 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 Okay, so this is df memory shell for watching non yielding started context results. Okay. Okay, so, and then we're just going to amend it. Okay. Okay, 1658. Okay, some more. Okay, what do we got? What do we got? Okay, so string input set context object has no attribute orchestrator. Okay, so run. Add context result. Okay, so 1946. Okay, so CTX orchestrator parent. Okay, otherwise orchestrator equals self. We are orchestrating. So I have a parent, but we're orchestrating this one. Okay, results is not defined. 1686. Okay. Context results. What's happening? Okay, so it's still running. Okay. Result. Okay. So task dot result. Okay. Okay. So okay. So it's hanging. Okay. Okay, so ICTX result. Okay, task add text result. ICTX result. Let's add. Task remove. Okay. Now task results. Okay, CTX outstanding. 0 tasks. Okay, if not more. So what do we do down here? Do we do something different? Versions for CTX. Task equals 1. Okay. And CTX. Create tasks. So this tries to create more context. Okay. If not more. Okay, so true. There is more. Okay. So context results. So context results. Result added. Okay. And more. Okay. More. Context. Okay. So then added, return false, added, return false. Wait, why is it saying that why are we returning false? Return more. If more equals false. Okay. I think the implementation is wrong because the other one was never tested. Okay, watch CTX. Okay. Okay. Result. Result. We got pass result. Okay, result. Oh, because we're supposed to be doing more, comma, CTX, comma, result. Okay. Okay. Expected to go 1. Expected to false. And then it's a list. Uh-oh. Ah. So we grab the whole batch. That's right. Oh, thank God. Okay. So, orchestra running. Okay, so now here we are. We're running kickstarting context test A. String input set context, so there's no fucking save. Alright, so let's just retry that one more time actually because I want to know why the fuck it's doing that. I want to know. Let's see if this works. Okay, yeah. This. Okay. Alright, so DF memory. Result. Everything. Okay. Okay. So now okay, so string input set context object has no attribute illustrator. Okay, so 315. Okay, so from child flow context created. Okay, child flow context system subflow context added. Okay, has attribute parent. So so we should do this first. Oh shit, okay. So receive result. Received result. Okay, shit. Oh my god, it's working. Oh my god, it's working. We actually ran two contexts and we received the results. Okay. Okay. This is fun. Okay. Okay, so run context run operations for CTX. Property must be set before registering with parent flow. Registering context creation with parent flow. Okay, so this notification say has no attribute handle. Okay, so notification set context object has no attribute handle. So that concerns me. So why is that? Notification set context object. So yeah. CTX. So somehow CTX is a notification set context. So what's going on here is CTX. Okay, notification set context. CTX. Notification set context. CTX. There's no attribute handle. So the previous CTXs did? Or no, they just didn't trigger it yet. Okay, I see. So task.def result. Okay, so notification items. Okay, so the notification items that we're passing in. Notification items. Notification items. Notification item is that tuple. I guess, is that added function not used? I'm confused. Okay, so object has no attribute handle. Notification set context. Eight. Okay, so CTX. Okay. It's not there. Okay, so let's see. Feels like we're getting close. Okay. All right. So CTX. Why it's CTX? So we're adding a result. Add context result. Okay, so that's why. So result CTX. There we go. Fuck. Awesome. Okay, great. Thank you. Oh my god. Okay, so received. I'm not happy with that variable naming, but we don't. Memory result. So CTX. Local variable login. Okay. Like we're only getting the one context right now. Okay. So why the received result. Okay. Operations for CTX. Okay, so sort of parent. So flow context result. Okay. Okay, so subflow context result is this. It's called here. ITTX add context result. Perfect. Okay, so we got it. Look, we got it in the parent flow. That's very exciting. Um, oh, years I've been working on this. Okay. Okay. We've successful receive result child. Uh, oh my God. We're thinking in parallel. Boom. All right. Fuck yeah. Fuck yeah, fuck yeah, fuck yeah, fuck yeah. Okay. Fuck yeah. All right. Thank God. Okay, here we go. Now we're cooking with gas. Okay, so and that's good because we don't have a lot of time left. So repo string. So repo string. Okay. So where's inputs repo string? Guest string URL result get repo spec. Okay. So my guess is there's something wrong with the get repo spec stuff. So I'm just going to replace all these with get repo spec. Let's get repo. Okay. So it has readme. Why aren't you running? Because I see a result which is okay. Let's give repo directory URL. Okay. Has readme. Okay. So why isn't it triggering? So result. Let's get repo. So has readme. So it has readme included. Let's see. Maybe. Okay. Has readme. Okay, so okay, so self.octx config data flow operations. Okay. Where is has readme, create readme, has readme. Okay. So the autodef input got autodef. Okay. Okay, so we'll make it pretty so we can see it. But basically, what's happening here is that the input and the output are not the same. They're not resolving to the same thing. So, okay, so let's say, okay, not sure if we needed most of that actually. Okay, so we need to go into div from div base, and we need to look at go into div types. We need to look at, okay, resolve if forward ref. Okay. So where did these come from? Actually, you know, it might be in div base def op. Okay. So here, create definition. Okay, so create definition, name list. Okay, so create definition. All right, let's say we should try new type of definition. Doesn't that try new type to definition? Okay, so new type to definition. Okay, so div types, okay, back to op. So basically, so your type to definition. Okay, so so this will take precedence over the other. New type to definition is not defined. So we're going to take this. Okay, so okay. inputs. Mm, mm, mm. Okay. So, list. Okay. So we have to use the name. Okay. Repo has readme inputs repo. Why is that? Definition. Okay. Where's the forward? We have to resolve the forward ref here. God damn it. Resolve if forward ref. Okay. Okay. Resolve forward ref. Attempted definition. Fragmentation. Fragmentation. Okay, so if is instance fragmentation function fragmentation else. What we're gonna do. Definition name. Mm. Optional. Where's the handle union step? Okay. 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 So if okay, definition name. Okay. Definition name. Okay. If. Okay. Okay. So why is it still different? Ah, fragmentation. Fragmentation. Okay, function type annotation. Let's get repo. Now let's get repo. Output result. Okay, so I have to do it down here to the output. Okay, so return type frame annotation. Intent. Okay. Definition name. Frame annotation. Okay. Unexpected indent. Okay. So result is Alice. Give repo. Fuck. 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 Outputs result. Alice get repo. Inputs result. Alice get repo. Why isn't it linking them up? Definition. Fuck. 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 Fuck.